10.4.1 Hyperbolas. The objective is to graph and write equations of hyperbolas. A hyperbola is a set of all points such that the difference of the distance from two fixed points, the foci, is the same. So notice that with these graphs, the graphs themselves are in blue. They do not create a closed shape. It's more like two parabolas opening away from each other. You'll also notice in the equation that there is a subtraction sign in front of the term that has the b squared in the denominator. The standard form of the equation of a hyperbola with a center at 0, 0 is the following. If the transverse axis is horizontal, you have asymptotes at y equals plus or minus b over ax. Those are oblique asymptotes. You're going to have vertices at plus or minus a0. If your transverse axis is a vertical, then you're going to have an a squared under the y squared term. Your asymptotes are going to be a over bx, and your vertices will be at 0 plus or minus a. The foci of the hyperbola lie on the transverse axis, c units from the center, where c squared equals a squared plus b squared. Draw the hyperbola given the following. So first off, we know that the center is 0, 0. All of the ones we're doing in this section are. But we know that because there's no hk with the x and y in the numerators. The vertices, since they are, well, since a is 9, or a squared is 9, and it's under the x squared term, then the vertices are going to be a change in our x coordinate. So it's going to be plus or minus a0. A squared equals 9, so a is plus or minus 3. So we have plus or minus 3, 0 as our two vertices. So 1, 2, 3. And then 1, 2, 3. We'll go ahead and count those out. The foci, c squared equals a squared plus b squared for a hyperbola, not the minus. So we have c squared equaling 9 plus 4. C squared is 13. And so our foci, since that's going to be a change in the x coordinate, is plus or minus square root of 13, 0. And the square root of 13 is just over 3. So our foci is just here and here. So the foci are always inside the curved portion of a conic section. It just so happens that for a hyperbola, that curved cut portion, they're facing away from each other. So the foci end up being like on the outside versus where an ellipse where they are on the inside. And then your asymptotes for this type of hyperbola is going to be plus or minus b over ax. So in this case, it's y equals plus or minus 2/3 x. So that means going up to right 3, and then down to left 3, down to right 3, and then up to left 3. So these are kind of our oblique asymptotes. And what those are for, those help us guide the drawing of our hyperbola. It's going to go through the vertex and kind of just curve around those oblique asymptotes. Draw the hyperbola given by y squared over 9 minus x squared over 16 equals 1. So this is one that's going to open up and down. Even though 9 is smaller than 16, it's not really because there's a negative with the 16 portion. So that's like a positive 9, then a negative 16. So 9 would be the larger or more positive number, I guess. We are still working with a center of 0, 0. This time for a hyperbola that opens up and down, your vertices are 0, comma, plus or minus a. So in this case, it's 0 plus or minus 3 from our 9 under our y squared. So we're going to go 0 and then up 3, 0 down 3, and we have our vertices. our foci, c squared equals a squared plus b squared. In this case is 9 plus 16, which is 25. So c is plus or minus 5, which makes our foci at 0 plus or minus 5. This is opening up and down, so our coordinate for our foci is going to be the y that changes. Let's go ahead and graph our foci. So up here at 5 and then down at -5. And then we know our asymptotes are going to be y equals plus or minus a over b. So in this case, it's y equals plus or minus 3/4 b. So that's a line that has a y-intercept of 0 and a slope of positive 3/4, and then the other one has a slope of negative 3/4. So 1, 2, 3, 1, 2, 3, 4, and then down 3, right 4. And then we can go up 3, left 4, and then down 3, left 4. So we kind of create this little box that's in the center of the, where the hyperbola goes. So we have our little oblique asymptote this direction. We have our oblique asymptote with the negative slope. And then our hyperbola opens along that. Write an equation of a hyperbola with foci at 0, -3, and 0, 3, and vertices at 0, -2, 2. So that means that a is plus or minus 2, which means a squared equals 4. We know that c equals 3, well, plus or minus 3. So c squared equals 9. So if we use our c squared equals a squared plus b squared, the first thing we should be paying attention to is the fact that it's the y coordinates that have changed. So this is a y squared over a squared minus x squared over b squared equals 1 situation. We already know that a squared is 4. And so we know that c squared is 9, so 9 equals 4 plus b squared. That means b squared is going to be 5, and b is plus or minus the square root of 5. But to write the equation, we just need b squared. So we're putting 5 underneath our x squared term, and we have the equation of our hyperbola.